Hi guys, I want to talk to you a little bit about probability today. So we just finished up our unit on circles. We're going to start to talk a little bit about probability, and we're going to look at um, what the definition is today of theoretical probability. Technically, is what this is the definition of, and we're also going to get a couple operative words with probability down. I feel like something that you guys know about probability is that answers come out to like fractions or percentages. And there's actually three correct ways you can write the answer for probability. You can do a fraction, you can do a percentages, or you can do a decimal where one would be a guaranteed that it's going to happen. And so, what probability is the desired outcomes over the possible outcomes. So, like for example, here I've got a quarter here. If I flip this, we can get heads, we can get tails. In other words, there's two outcomes. And so, when I flip a coin, a lot of people say, it's 50-50. It's a 50% chance one way or the other way. And that's because basically the probability is one half or 50%. Desired outcome, let's say you're going for heads, the desired outcome is heads. The possible outcomes are heads or tails. That's all you have to pick from. So there's one desired outcome out of the two possible outcomes. So one half. And that's what probability is defined to be. Now, I just wanted to explain this a little bit. Theoretical probability and experimental probability are not always exactly the same. If I flip this coin 4 times, am I guaranteed to get two heads, two tails? No. However, that's the most likely outcome. And if I were to flip this coin instead of, let's say, 4 times, let's say I flipped it 1,000 times, I would be pretty close to 500 heads and 500 tails. And so basically, as you do experiments, the higher number of events occur, the closer that experimental probability gets to being the theoretical probability. And so we're going to be dealing with the theoretical probability, but just keep in mind there is a difference between the two things. So probability, desired outcomes over possible outcomes. Now, what we're going to do is we're going to start talking about sample space here, and then we're going to really concentrate on some operative words today in probability. So that first part is really review of how probability works. So we're going to try to make what's called a sample space of this example. So here's what we've got going on. We've got a bag with some marbles in it. We've got a green, a blue, and a yellow in there. So there's our marbles in this bag. All right, what we want to do is we want to see what's the probability of picking a certain color marble out of here. Now, using our theoretical model of probability here, desired outcomes, let's say we want to pick a green one. So we have one green one out of the 3 marbles, and so the probability that I just reach in here and randomly pick out the green one is 1 out of 3, and I did not, which isn't a surprise. I only had a 1 in 3 chance of doing it. And so sample space is a list of all the possible outcomes. So we're going to do two things on this example here. You notice it says we're supposed to pick a marble from the bag with a green, a yellow, and a blue, and put this part, and flip a coin. So if we do both these things, if we pick a marble from a bag with a green, a yellow, and a blue, and flip a coin, what's the sample space, or what's a list of all the possible things that could happen here? Well, for the marble part, a couple things could happen. We could get a yellow, we could get a green, we could get a blue. And so we could get, let's go with green first because that's the first one I have listed. We could get green, we could get yellow, or we could get blue. Now, if I get green, but then I flip a coin, I could get green and then heads. But couldn't I also get green and then tails? And so we could do green heads or green tails. We could pull out a yellow marble and flip heads, or pull out a yellow marble and flip tails. Or we could pull out a blue marble and flip heads, or pull out a blue marble and flip tails. And that takes care of every different scenario that could happen there with these two things going on. And so if you notice, our total possible outcomes that could happen, we have six of them in this case. Green heads, yellow heads, blue heads, green tails, yellow tails, blue tails. That's the things that could happen. Now, with this information, this is going to be really helpful for this next part here. All right, let's see if we can answer a couple questions that have to do with this experiment. What is the probability of picking a blue marble and flipping heads? All right, this word is an extremely important thing. This is basically an operation, a math operation, whether I say and or you notice down here we've got an or. That's really telling you what you need to do. So and, that means they both happen. Another name for this is the intersection. Where do both of these things happen at the same time? So what's the probability of picking a blue marble and flipping heads? Well, do you notice we have 6 possible outcomes here? And how many of those outcomes do we have blue and heads both happening? Well, if we're looking for blue and heads, this is the only one where that happens. So the probability of blue marble and heads is only 1 out of the 6 possibilities we have. We have 6 different things that could happen. There's only one case where we get blue and heads both. And you can write your answer just like this. As a fraction is good. It should be simplified, but 1 over 6 doesn't simplify, so that's fine. Or you can write it like this. If you put this as a decimal, it's 0.16 repeating. Or if you like a percentage, it's like 16.6 repeating percent. All 3 of those answers are perfectly acceptable answers when we're talking probability. And on every probability problem, unless the question specifically says put your answer as a fraction, put it as a percentage, put it as a decimal, they're all 3 acceptable answers. All right, so let's see if we can look at this one now. So and means they both have to happen. This is an or. What is the probability of flipping tails or picking a green marble? All right, now or means that if either of those things happen, then it's a desirable outcome. They don't both have to happen. If either of them happen, it's a desirable outcome. And so let's start to see if we can come over here back to our sample space and underline all of the desirable outcomes. So any place where we flip tails is a desirable outcome. All those are good. Or if we pick a green marble, that's good too. Which kind of means this one's like doubly good, but we can't count it twice, it only happened once. And so if we look over here, we've got all those are desired outcomes because we got the tails. That's still a desired outcome because even though we didn't get the tails, we did get green. And or means if either of them happen, it's a desirable outcome. And so if you notice here, out of the 6 things that could happen there, 4 of them are desirable outcomes. So we've got 4 out of 6. Now this is one that does simplify. If you're going to leave your answer as a fraction, you shouldn't leave it like that. If we simplify that down, they both divide by 2, right? We get 2/3. And that's fine. Or if you really like a decimal, you do 0.6 repeating is what that comes out to. Or if you really like a percentage, that's 66.6 repeating percent. So any of these 3 answers here would be good on that problem. All right, everyone okay with that part so far? So remember, and is they both have to happen. Or means if either of them happen, it's still a desirable outcome. They don't both have to happen. All right, so let's look at another example here. And actually, the first thing I want to do here is look at a little bit of notation that goes along with some of these words that we were just learning. So if you look up at the top here, on the top left, we've got probability of A. The way we're going to write that is P and then in parentheses A. That means the probability of event A. And then we noticed or and are a couple of important words for probability. The way that we say or in like this notation is this U looking thing. It's like the U without a stick, basically. And so this is the probability of A or B. Another word for that in set theory is called the union of A and B. And so it's A or B. And then and is just the upside down version of that symbol. So instead of the U without the stick facing the way a U does, we turn it upside down. That's the probability of A and B. All right, so that's some notation that we might see. And I know you guys are going to see that on the worksheet today, so just keep that in mind. This is and, that is or. And then another one that's an important word. If we ask for the complement of an event, the complement of an event is the probability that it does not happen. So the probability of pulling a green marble out of here was 1 out of 3. The probability of not pulling a green marble out of here then would be 2 out of 3, the other things. So that's what that means, probability that it does not occur. So something that we're going to do some questions about in this unit is a standard deck of playing cards. And I realize that some of you guys might not be super familiar with how a deck of playing cards works. So on Google Classroom, there's actually going to be a reference sheet for what a deck of cards looks like and what happens with all the face cards, all the different suits, the colors. And so if you're not real familiar with the deck of cards, refer to that. It'll be helpful. So we're going to say you pick a card from a standard deck of 52 cards. And event A is you pick a 7 from that deck. Event B is you pick a heart from that deck of cards. And event C is you pick a queen from that deck of cards. All right, so we've got multiple different events here. All right, so let's look first for the probability of A. Now there's 52 total cards. Remember, probability is desired outcomes over total possible outcomes. If there's 52 cards, that's my total possible outcomes. And then that's going to go on the top, or on the bottom, and then on the top we need to figure out, of those 52 cards, how many of them are 7s? And so we've got the 7 of hearts, the 7 of clubs, the 7 of spades, the 7 of diamonds. So we've got 4 7s in a deck of cards. So the probability that we pull out a 7 from that deck of cards is 4 out of 52. This is not simplified, so we shouldn't leave it like this. We can either change it to a decimal or a percentage, or we could just simplify the fraction. I'm going to simplify the fraction. 4 goes into both of these. 4 divided by 4 is 1. And then 52 divided by 14, or 52 divided by 4 is 13. And so this is 1 out of 13. All right, the probability that you pick a heart for part B, probability of B, probability that you pick a heart. All right, there's 4 suits in the entire deck of cards, and there's an even number of each. If you think of it that way, you could actually almost figure out that probability just thinking that. So if there's 4 and they're all equally likely to happen, what's the probability you pick this one? 1 out of 4. If you want to go a little more in depth with it, there's 52 total cards, and there's 13 cards of each suit, which means there's 13 hearts. So it's 13 out of 52. But if you divide both of those by 13, like we said a minute ago, you get 1/4 for the probability that you pick a heart out of that deck of cards. All right, now let's get to some of these things. So this one says probability of A and B. I want to put this in words first. So this says the probability that you pick a 7 and a heart. So what's the probability that if you pick one card from a deck of cards, you pick a card that's a 7 and a heart at the same time? Well, if you think this through, isn't there only one 7 of hearts in a deck of cards? And so since there's only one 7 of hearts, there's only one card that's going to satisfy both of those things at the same time. So that means the probability is 1 out of 52. There's only one card that's a 7 and a heart at the same time, and that's what needs to happen when it's and. It has to satisfy both things. All right, and then D, this symbol means union or. So what's the probability of A or B? So what's the probability that you pick a 7, or, you know what, I'm going to change this to C first. So what's the probability that you do A or C? So what's the probability that you pick a 7 or a queen? Well, we need to think. How many 7s are there in a deck of cards? We got 4, right? How many queens are there in a deck of cards? That's another 4. So how many total desired outcomes do we have now? So we've got 4 7s, 4 queens, which means we have a total of 8 cards that would be a desirable outcome. If you pick a 7 or a queen, it's good. And so we've got 8 out of 52 for desired outcomes. Now we shouldn't leave it like that. We could change this to a decimal or percentage or simplify the fraction. I'm going to simplify the fraction. They're both divisible by 4. 4 times 2 is 8, and 4 times 13 is 52. So that's 2/13. All right, and then part E. What's the complement of the probability of B? All right, well, let's think about what the probability of B was for a second. We did this right up here in part B of this. Probability of B was 1/4. What's the probability that that doesn't happen then? Well, if a probability is 1, that means it's guaranteed to happen. That's all possibilities, basically. And so, really, there's a couple ways you could think of this. If there's 13 cards that satisfy that, we want to know how many cards don't satisfy that. So we could do 52 minus 13 and put that over 52. Or we could just think of this. If 1/4 of the cards do satisfy this, all the other cards, the other fraction of cards, won't. And so basically we're saying 1/4 plus what other thing gives us 1. And 1/4 plus 3/4 gives us 4/4, or 1 in other words. And so the complement of drawing a heart, the probability of drawing a heart is 1/4. The complement of that would be everything else, which is the other 3/4. Okay? So that's what complement means. What's the probability that drawing a heart doesn't happen? And then this one, I'm actually not going to completely answer this question. I'm going to leave it to you guys to think about just a little bit. And so a little bit of a cliffhanger ending here. So probability of B or C. So that's the probability of picking a heart or a queen. All right, so hearts. We already looked at this. For hearts, there's 13 in a deck. For queens, there's 4 in a deck. So we've got 13 hearts. We've got 4 queens. If I would add those together, I'd have 17 cards that I want. However, that sure seems like that should be the case. That's not right. And I'm not going to tell you why yet. Tomorrow, that's going to be the big thing we talk about. We're going to call it disjoint or overlapping events. And so since that's the big thing we're going to talk about, we'll see if you guys can just think about that and figure out why, even though there's 13 hearts and then there's 4 queens, that 17 out of 52 is not the right answer for that. So the big thing for today, though, is I want you to get the ideas of and or down. These are the big things we're going to be using here and what it means to take the complement of an event. And so you're going to be doing some of that and using just the basic definition of what probability is, which remember is what you want to happen over everything that could possibly happen.